Hi, welcome. We are looking at word problems and specifically using systems of equations. On the very first example, we're looking at a question where a tour company has 92 tourists as clients. The company sends out tourists as passengers in 8 vehicles, some cars and some minibuses. Find the number of cars and minibuses the company used if each car had 4 tourist passengers and each minibus had 16 tourist passengers. So while doing questions like this, the very first thing you want to do is define variables. And what are the variables? It's usually helpful if you define your variables based on what the question is asking. Now, the question is asking you, find the number of cars and minibuses. And so that's exactly what we're going to use to define our variables. Okay, so we're going to say, let the number of cars be C, and let the number of minibuses be B. Now, we have 92 tourists. That's the opening line, right? And they used 8 vehicles. So the first equation you want to write is the number of cars plus the number of buses is equal to 8. Okay, so that's coming out of 8 vehicles. Okay, so that's where that 8 is coming from. And then now there are 92 tourists who are packed into these cars and minibuses. And each car has 4 tourist passengers. So now we have 4 tourist passengers in each car, right? So we're going to have 4 multiplied by the number of cars, plus we also have 16 passengers in the minibus. Okay, so that is going to be 16b, and that gives us 92 passengers. Okay, so this 4 comes from the 4 tourist passengers in cars, and this from the bus, and then you multiply 16 times b and add it with 4c, you get 92, right? So here we have a system of equations, 1 and 2. We want to solve the system. Now, we don't know at this point which is a better option. Maybe you can use substitution or elimination. It really doesn't matter in this case. I'm going to just use substitution for now, but I have to isolate a variable. So I'm going to use say, equation 1. Using equation 1, right? I'm going to isolate b. B is 8 minus c. Okay, so that is from equation 1. Let's just call this equation 1 prime. And then from there, right? And from there, we have, we take that equation b from 1 prime and put it into b is equal to 8 minus c. We're going to put that into equation 2. So we have 4c plus 16 multiplied by 8 minus c equals 92, right? So you get your calculators out. 4c plus 8 times 16, that's 128, minus 16c equals 92. And then collect like terms. 4c and 16c together become negative 12c equals 92 minus 128. So 92 take away 128 is 36 or negative 36, right? So c is negative 36 divided by negative 12, and you have c equals, so next page, so c is equal to 3. So they took 3 cars. Now we can put this back into equation 1, and we can get C plus B. Okay, so put that back into equation 1, and you get C plus B equals 8. So that is equation 1. So you have 3 plus B equals 8, and B equals 8 minus 3, and B equals 5. So your final answer is, therefore, they took 3 cars and 8 minibuses. Right? So that is the answer. Could you do this question using elimination? Yeah, you could. You'd still get the same answer, okay? You probably want to multiply the very first equation by -4 and get rid of the C, okay? So you could also do that. I'm not going to do it, but just for those of you who are kind of curious, I'll just give you a quick hint, right? You can say, you can just say method 2, right? And then you can quickly try that out. You have C plus B equals 8. That's equation 1. Multiply the equation by 4, all right? 4 times C plus B. Actually, I'm going to multiply by -4 because I have a positive 4C in the next equation. -4, and then equals 8 times -4. Okay. So here you have -4C minus 4B equals -32. I'm going to call this equation 1 prime. And then the second equation we had was 4C plus 16B equals 92. Then you have 4C plus 16B is equal to 92, and that was the second equation, okay? And then you can add those 2 equations. So 1 prime plus 2, and then this will cancel out, and then you can go with just the B. So 16 minus 4, and that's 12B, is 92 minus 32. So that is, 92 minus 32 is 60. So then you have B equals 5, and then etc. Okay, you can find the value of C. So this is a question where you could have used substitution or elimination, or if you had a grid, you probably could have graphed it as well, knowing that both C and B have to be integer values. So this is also a good question for graphing if you plan the scales carefully, or you have enough grid space, then you should be able to also do that by graphing. But clearly, using algebra is more convenient. Okay, right, let's do the next question. 21 students and 7 teachers attend a theater performance. Together, they spend 1,225 for their tickets. If adult tickets are 15 more per person than each student ticket, how much did each student ticket and adult tickets cost? So clearly, now we are looking at cost, right? So we're looking at the cost. So it's going to label your variables using cost, okay? Let the cost of student tickets equals S. What I don't want to see is let student equals S, okay? That is something I do not want to see. You want to talk about a variable that's a measurable quantity, like number of students, or the cost of the ticket, or the number of vehicles, or the number of kilometers driven. Just don't say let the buses equal to B and cars equal to C, right? So we want to have something that can actually be counted or measured, okay? So in this case, cost is a measurable quantity. So we're using let the cost of student tickets equals S, and the cost of adult tickets equals A, right? I'm just going to use uppercase. So we have 21 students and 7 teachers. We cannot write S plus A equals 21. That would not be correct, right? Because we are looking at the cost of each ticket. So that probably is not correct, right? What we could do is we can say the adult tickets are 15 more per person than each student ticket, right? So we're going to do that. That's what we're going to do, right? So we're going to say adult tickets are $15 more than student tickets. So if you take the student ticket and then you add $15 to it, that's what you're going to pay for the adult ticket. Or you could write it as A minus 15 is equal to S, one way or the other, right? So that's your first equation. So we have 21 students and 7 teachers. And so now we're looking at the cost. So 21 students times the cost of the tickets plus 7 teachers, right? So they are adults, right? The cost, so this is the cost equation. Okay. And so that gives me 1, 2, 2, 5. So that's what they spent. Okay, so that's your second equation. You can either use substitution or elimination. Now, since we have already isolated A, it makes sense to use substitution here. So substitute for A from 1 into equation 2. So you have 21S plus 7 times, instead of A, I'm going to write 15 plus S equals 1, 2, 2, 5. Okay. So 21S plus 15 times 7. Oh, sorry. 15 times 7 is 105. Plus 7S is 1, 2, 2, 5. So collect like terms. 28S is, sorry, let me not skip steps, plus 105 is 1, 2, 2, 5. 28S is 1, 2, 2, 5. Take away 105. So I have 1, 2, 2, 5. Take away 105. And that gives me 28S is 1120. And S is equal to that divided by 28, which is 40. Now, what is S? Is it the number of students or is it the cost of the student ticket? Okay, yeah, that's the reason why we need to define variables and know what it is. Okay, so S, that is the cost of the student tickets. Okay, so that is how much student tickets cost. And now we can use the very first equation. Using equation 1, adult tickets are $15 plus the student ticket. So adult tickets are 40 plus 15, so $55. Okay. So you can say, you can write your final answer. Therefore, student tickets are $40 and adult tickets are $55. So those were 2 examples of systems of equations. I hope that was helpful. Thanks for watching. Bye-bye.